Welcome back. So we're now moving on to breadth first traversal of a graph. So breadth first prioritizes visiting all of the neighbors at a given depth before moving downwards or visiting neighbors of neighbors. So let's take a look at an example first. With a tree, it's always easier to talk about because we can just say horizontal before vertical, before descending down. With a graph, though, it's a little more complicated, but we can still talk about depth. There are layers, there's levels. It's actually called height. So if we start from 0, there are 3 neighbors of 0. So we could call each one of them 1, 2, and 9. Each one of those have a height of 1. So we could put a little 1 next to them. Then if we go from 1, there are 3 neighbors of 1, 11, 3, and 6. Those would have a height of 2. If we look at 9, there's 8 and 4. Those have a height of 2. They are 2 jumps away from 0. 1, 2. Something like 10 would have a height of 3. So when I say height, just imagine a little number here, a 1, and a 1. Then we have a 2, 2, and a 2. And we're going to visit all of the things on the same height, horizontally in this case, or sort of diagonally across, before we visit their neighbors. So here, I'll play it for you. Again, the order we go in this case, it's going to be 1, 2, 9. On this website, they use the lowest number first, I believe. But we could also go 9, 2, and then 1. Either way, we're prioritizing visiting neighbors, all neighbors for a given node or vertex before visiting neighbors' neighbors. Okay, here we go. So you can see it actually draws those little numbers. And then from 1, we visit all of its children. I shouldn't say children, all of its neighbors. And we keep going. Now, of course, we have to keep track of what we've already visited because, like here, if I pause, we've already visited 5. So we don't want to continually visit it again. There we go. We're almost there. Okay, so the actual order that we go in doesn't matter that much. Like I said, if we're going to start 9, 2, and then 1, or 2, 1, and then 9, it's just that we're fleshing out all of the neighbors for a given vertex first. So on our more simplified graph, if we start from A, we could go E and then B, or we could go B then E, and that's what I coded in here is A, B, E. Then we go back to B and visit all of its neighbors. So we've already done A, so we have C and D. Then we go back to E, and we visit all of its neighbors, but we've already done A, we've already done D, so its only neighbor that's left is F. And then from F, we've already visited everything else, and we're done. So in the next video, I'll have the pseudocode.